Hello there, Mr. Sutton here, bringing you the Algebra 2 Honors 10-5 homework solutions. In this one, we're focusing on graphing the other trigonometric functions, specifically tangent, cotangent, secant, and cosecant. We'll see all four of them over the course of this assignment. On this problem, we're doing g of x equals 1/3 tan of 2 pi x. Let's start with figuring out the transformations happening. The 1/3 out here gives us a vertical shrink. The 2 pi inside, since that's bigger than 1, it's giving us a horizontal shrink as well. And now for the parent table, we have negative pi over 2 through pi over 2 with all of the asymptotes and points in there. And for the g function, since I have this 2 pi inside the function, for my x's I'm doing 1 over 2 pi times x, or x divided by 2 pi, either way. And then we have 1/3 times y for the y values because of that vertical shrink. So for the x's, we've got negative pi over 2 times 1 over 2 pi. The pi's are canceling, and we just have basically negative 1/2 times 1/2, which is negative 1/4. And now down here, negative pi over 4 is going to turn into a negative 1/8. If I multiply that by 1 over 2 pi, 0 is still going to be 0. Pi over 4 becomes 1/8 positive, and then pi over 2 is now going to be a positive 1 over 4. For the 1/3 times y's, undefined is still undefined. Negative 1 is now negative 1/3. 0 is 0. 1 is 1/3. And we've got this undefined still being undefined. Judging by my x values, I think if I go by 1/8 on the horizontal, that'll do it. For the y values, I'm thinking 1/3 probably makes sense given my scale here. So we've got negative 1/4, which is over here, negative 0.25, and that's an undefined value, so we have an asymptote right there. Then we have negative 1/8, negative 1/3, which is down here, 0, 0. 1/8, 1/3, and an asymptote at 1/4. And then here's my tangent curve through those. For this problem, we are graphing tan of 1/2 x. The 1/2 in there, since that's less than 1, gives me a horizontal stretch. For my tan table, here it is. We've seen the parent table a few times. And for the g function, we're doing 1/2 x in the function, so that means we're actually doing the reciprocal of that, 2 times x, for the actual rule that we're applying. There's nothing outside the function, so the y values are not going to change at all. So for 2 times x, we multiply each of these x values by 2. So negative pi over 2 is just going to become negative pi. Negative pi over 4 becomes negative pi over 2. 0 is 0. Pi over 4 is now pi over 2, and pi over 2 is now pi. For the y values, we just keep the originals. We're still undefined at negative pi over 2. Then we've got negative 1, 0, 1, and undefined. So judging by the x values, if I go by pi over 2's on my horizontal, that'll give me everything I need to show all these essential spots. And then I can just go by 1's on the y-axis. So I have my first asymptote at negative pi right here. I have the point negative pi over 2 comma negative 1, and then 0, 0, pi over 2 comma 1, and another asymptote at pi. And then let me just draw my tangent function following the asymptotes and going through these 3 points. Let's go ahead now and graph 4 cosecant of 1/2 x. For transformations, the 4 out here is giving us a vertical stretch. The 1/2 inside is also giving us a stretch, but horizontally. And now for the parent table, we're going from 0 to 2 pi with all the points in between there. And then for the g of x function, we've got a couple things going on. For the x's, this 1/2 inside means we're doing the reciprocal of that, 2 times x for the rules. And then the 4 out here means we're doing 4y. So for the x's, multiplying all these by 2, we've still got 0. And then pi over 2 becomes pi. Pi becomes 2 pi. 3 pi over 2 is 3 pi. And 2 pi times 2 is 4 pi. 4 times all the y values is going to give me, well, this is still undefined, but now we'll have 4, undefined, -4, and undefined again. So for x values, I can go by, it looks like pi. For y values, I could probably get away with going by 1s, or I could go by 2s or 4s. Doesn't really matter. I guess I'll go by 2s. So our first asymptote, we have 0 for that one. And then we have pi comma 4 right there. And then 2 pi is an asymptote. We have 3 pi comma -4 and asymptote at 4 pi. Then we have a branch up here and another branch down here. To graph 1/2 secant of pi times x, let's go ahead and get our transformations mapped out. The 1/2 outside gives us a vertical shrink. The pi inside, since pi is larger than 1, is giving us a horizontal shrink. For the parent table, we've got all the values from negative pi over 2 to 3 pi over 2. And for the g function, for the x's, the pi inside means we're multiplying by 1 over pi for the x's. And the 1/2 outside means we're doing 1/2 times y. So for the x values, multiplying all these out, negative pi over 2 times 1 over pi, the pi's cancel, so that's just -1/2. And then 0 is still 0. Pi over 2 becomes just 1/2. Pi becomes 1. And then 3 pi over 2 is just going to be 3 over 2. For the y values, undefined is still undefined. 1 is now 1/2. Undefined is undefined. We have -1/2 and then undefined. For the x scale, if I go by 1/2, that'll fit these nicely. And for the y scale, I'll probably want to go by 0.5s to fit these half values here. So we've got the asymptote at -1/2 right here. And then we have the point 0, 1/2 right there. Asymptote at x equals 1/2 is here. We have 1, -0.5 right here. And then 1.5 or 3/2 is our other asymptote. So there's a branch up here above the x-axis and another one down here below. On this problem, we're trying to graph 3 cotan 1/4 of x. For the transformations, we have a 3 out here giving us a vertical stretch since that's bigger than 1. And this 1/4 inside, since that's smaller than 1, this gives us a horizontal stretch as well. So stretching in both directions. For the parent table, here's our cotan table from 0 to pi. And for the g of x table, for the x values on this one, the 1/4 inside means we're doing 4 times x for the actual rule. And then we have 3 out here giving us 3 times y for the y values. So for the x's, we're just multiplying each of these by 4. So 0 is still 0, but pi over 4 is now just pi. Pi over 2 is going to be 2 pi. 3 pi over 4 is 3 pi, and you can probably follow the pattern here. 4 pi is next. For the y values, multiplying by 3, undefined is still undefined, and then we have 3, 0, -1, or -3 rather, and also undefined. It looks like I can go by pi's for my x values, which is kind of nice. For the y values, we can either go by 1s or 3s. Won't really matter. I can fit 3s if I just go by 1s. So let's do our vertical asymptote at 0. And then we have pi, 3, 2 pi, 0, 3 pi, -3, and 4 pi is our other vertical asymptote. And then let's just draw our cotan curve through those points and approaching those asymptotes.